Well, hopefully everybody did a good job with mean, median, and mode and things like that. We're able to work with the calculator, Google Sheets, whatever you were using for technology. Like I said, if you do have questions about any of this stuff, just let me know. So the very first sentence in here is actually a kind of a good question. Why do you need just one measure? Why do we need more than one measure of center? Well, the first example we saw kind of showed that our measure of center for that example was all over the place. So that was kind of a good reason. But why couldn't we just pick one and say, hey, let's always use that one, for example? So here's a small example that kind of demonstrates that in a major way. So imagine we had a little small company that had one CEO who made $1 million a year and 9 other employees who make $40,000 a year. So if we look at the mean salary of this company, add up 40,000 9 times, add a million up, and then divide by 10 total, we'd end up getting that the average salary in the company is $146,666.67. Whereas if we did the median, line these all up lowest to highest, then in that case, the median salary is going to be $40,000 a year. So in this case, which one of these kind of gives you a better estimate of what the normal working person is actually making in this company? Sure, it's the median. And so it's amazing, like, what a difference, like just by having this one outlier, that $1 million, it's pulled the mean 100 and some $1,000s to the right. I mean, it is humongous. I mean, it's changed this data in such a way that it's just crazy how far the mean's been moved over. And that's what the odd part about the mean is. So the mean you would think would actually be the go-to for trying to find the center, but it turns out the median actually usually is the better job because it really does measure the true center. So if you ever actually go like online or go around like populations and things like that, like when they talk about like the household income, it's always the median household income. It's always like the median price for a house. Because again, like the problem is like if you live in Frederick County, like it's possible maybe somebody has a house that's worth $10 million, but does everybody in Frederick County have a $10 million house? Heck no. But if you throw that $10 million house in along with all the other price values, it's going to make these houses look like we're worth, the middle income worth so much more than what it probably actually is. So it only takes one or two like big data values or small data values as an outlier to really throw off this data and make it not look so good. So when we're talking about skewed data, that's actually what we're talking about here, where it's going to either get pushed to the right or pushed to the left because of this skewed part of the data and these outliers. So when we're talking about sensitivity to outliers, the mean is very sensitive because if you think about it, the mean actually uses every single data point to calculate that average. It adds them all up. It includes those outliers. So like in above, that $1 million outlier threw that mean completely out the window. Where median, since it just lines them up lowest to highest, I mean, it could have somebody making $100 million salary out there on the right, and it wouldn't matter. The median still would have been 48,000 in that problem above. So the median is not affected by outliers. And so this just gives you a little example of what we're talking about. So the middle one is kind of the optimal. This is like what we're hoping to have in a set of data. We're hoping that the data is symmetric, which means the mean and the median are relatively close together. Now they may not be exactly the same, but like maybe one's like 2.4 and the other one's like 2.5, 2.6. They're relatively close, not a major difference, like above where it was over $100,000 difference. So skewed to the left means that the mean would actually be to the left of the median. So in that case, that means that there are outliers over on this side. So there's some really, really, really small numbers to the left that's actually dragging that mean to the left. So that's what it means when it's skewed to the left. So it's kind of weird. It's hard for me to look at these graphs sometimes because all the big bars are on the right, but we're saying it's skewed left. But what you're trying to do is you're trying to figure out where the mean is in relationship to the median. So in this case, the mean is on the left of the median, so we say it's skewed left. So our example up above would be this situation where the mean is greater than the median, so that means our outlier is living over here, so that $1,000,000 was over on the right, where everybody else's salary was to the left. So it's skewed to the right. So when you think about left and right, think about that's where the outlier would live. The outlier would either live on the left or the outlier would live on the right in that case. All right. Is that okay with everybody? All right, perfect. So let's look at a couple examples here just so we can see. So in this case, so it's asking if this is skewed or symmetric. And so this one actually gave us a graph, but we can actually do this without even looking at the graph. So all we need is kind of the mean and the median and kind of base our decision off of that. So just so I don't bore you guys, I actually went ahead and calculated this ahead of time. So in this case, the mean for this data is 4.25 and the median is 3.5. And again, I just do it in my calculator and did it using 1var stats, or again, you can throw it into Google Sheets and do the 1var stats. So in this case, what do we think? Does this look symmetric? Does it look like above? Does it look like it's skewed left, or does it look like it's skewed right? Can we tell which way it would be skewed? Well, if you notice, we've got this kind of big outlier. I mean, these guys aren't great either, but this 14 is definitely throwing off this data, and that's why the mean is so much bigger than the median in this case. I mean, it doesn't seem like it's that much bigger, 3.5, 4.5, that doesn't sound like it's that big, but in the grand scheme of things, that's kind of a big jump. When we're saying things are close together, we mean they're like a tenth apart or something like that. We want them to be relatively close. These are kind of far off in that case. And the reason being is we've got that 14 that's way out on the right. So some country just won a lot more gold medals and they kind of screwed it up for everybody else data-wise. So in this case, we would say it was skewed. And since the outlier is to the right, we'd say it's skewed right. Or you could say the mean was to the right. So either way, whatever makes you remember skewed right or skewed left in this case. All right, so got some more. Again, these are the same ones I've been torturing you with over and over and over. So again, take these guys. You've already found the mean and the median in the last section. So now use those data to try to figure out whether you think it's symmetric or whether you think it's left or right skewed and make a decision from there. So otherwise, good job. I'll see you guys in class tomorrow. If you have any questions about anything, let me know. Otherwise, great job today.